sometimes where you're going to get the right answer, but because of sloppy notation, you're only going to earn half of the points. So it's very possible to know how to completely answer a limit question, but if you're not writing it appropriately and with the correct notation, you're only going to get half of those points. Let's start off, please, let's take a look at this first one. We have a piecewise function. It's defined on one side, on the left-hand side by this rational expression here, and on the right-hand side it's defined by the reciprocal function being squared. Let's take a look at the first one for A. You're taking the limit as x goes to negative infinity of this function. Now, as I go to negative infinity, hands up please if you can tell me which piece I would be going through and working with. The upper piece or the lower one. We got 2 of you that can tell me. 3. Something for more. 4. The upper piece. So, to show what I'm doing, and again, this is you justifying the answer. And it's not unreasonable to expect you to do this. So I go through and say, all right, I'm going to go through and I'm going to take the limit as x approaches negative infinity of that expression. So if you don't have that down, get it down now. What is that going to go to? Well, we'll say it this way. Look at the growth rate of the numerator and the denominator. Are they different or are they the same? The same. When I plug in a negative value in the numerator, or negative gigantic values, the numerator will be negative divided by the same -1. Who can tell me what we get as we go out to the left for our limit as x goes to negative infinity? No? We get 1. If you know that the limit as you go to negative infinity is 1, what is the horizontal asymptotes equation going to be then as well? Because that means it's leveling off to a value. Y equals 1. So sometimes we're going to give more than we need to in our classwork so you can reinforce and sort of try to tie everything together. Now let's go out to the right-hand side. So I go through and say, well, I've got a limit as x approaches infinity, or positive infinity, of 1 over x squared. Who can tell me what we would get as we trend out to positive infinity? What are those function values going to? John?
0.
So what is your horizontal asymptote equation going to be then?
Y equals 0.
Now we're going to start to approach this from different sides. I'm going to take and evaluate out the limit as x goes to 0 from the left-hand side. So we said before we're coming at something from the left. That's going to be using that top piece. So I'd say this. Well, this is kind of awkward. This is almost too easy. How can I evaluate out this limit? This one-sided limit, by the way. What's that? Yeah, you plug a 0 in. And when I plug 0 in, what value did you get? 2. Does that mean that it has a horizontal asymptote at 2? No, because it's not end behavior, it's local behavior. It's in the middle of the graph at 0. How about on the other side? When I do this, I'm taking the limit as we go to 0 from the right-hand side. That means I'm using the reciprocal of the squared function. Think about what that's going to go through and give you. You're plugging in a really, really small value of 0, really, really close to like 0.000001, and squaring it, which means it's even smaller than before. What is that right-hand limit going to? Yeah, 2, 3 of you? What kind of infinity? Terrific. You've got 1 over a profoundly small number is going to be a profoundly large number. So a positive infinity. Questions on that? Now, for this next group, I'm going to show out and justify my answers. These are sort of AP-ready questions from your books. Oh, and we still haven't done books yet. At some point in the next week, remind me if we have a minute or two, we'll do books. Looking at what we have for the first question, we need to find the limit if this exists. Oh, let's do this as well. Take your calculators, please, and set them down. You don't turn them over. You don't need your calculators to do these. And if you do, you're creating a bad setup for yourself. looking at what's there, if this limit exists, or find the limit if it exists, I look at that and I'm going to start off by plugging in a 3. I immediately know that the value, or the function, is not defined at 3 because I get a 0 in the denominator. But what the numerator is almost as important. If I do this, it would be 3 squared, which is 9, minus 3 minus 6. So 9 minus 3 minus 6 is going to give me what value? 0. When you get a fraction by, or you're taking a limit by direct sub and you get 0 over 0, what is that called? Let's start off with that. Yeah. And what does that indicate you should try to do? In this case, that means let's try to factor it down. Now, what I did for this question, and this is the level of work you would expect to show on anything that's graded in here, you need to rewrite it out, including with the limit. Show that you factored it successfully. That's step 1. The next thing that we would need to do then is rewrite it out, because now we're going to take the limit as x approaches 3, not of this big rational expression, but I'm going to take the limit as x approaches 3 of what? Hands up if you can answer that. The quantity x plus 2, and the reason that I'm going to be such a stickler about it is I had my first year doing the Calc through MCC. They audited my test, and almost every kid's score got lowered by 1 point because I said that was acceptable. Can anybody tell me as to what you need your parentheses there? It's not going to give you a different answer, but if you don't show it, the argument of the limit is not appropriate. So from here, the next thing that we would do is do a direct sub, and what did we get as an answer? 5. Questions on that? Next one up is B. You're given that. Notice, by the way, and I love this, some of us are a little slow to pick up on what we're going to be testing you with limits and stuff like that. Looking at what's there, notice it's asking you to take the limit as x approaches 2 from the positive side of f of x. Shockingly, this is a piecewise function, and guess where the transition is going to happen? 2. And pretty much every question that we do, where you're taking the limit is going to match where there's the potential for a discontinuity. So to start off with this, I'm taking the limit as x approaches 2 from the right-hand side. So to start off with, its limit as x approaches 2, I write that out, except now I can replace the f of x, because which piece am I going to be using? Hands up, please, if you can answer that. Which piece would I be using? Yeah? What would I do now to evaluate out that limit? Okay. And what do you get as an answer? Should your paper look like a carbon copy of that? Absolutely, because if it's not there, and again, we're going to have some of you that come in and you go on a test where there's 40 total points, and you're losing 2 out of 4 because you know what you're doing, but your notation is lazy and incorrect. That's a lot of credit to be losing, especially with the fact that we don't do tons of extra credit to begin with, and the fact that your tests count for such a substantial portion of your grade. Your tests count for half of your mark. So you've got to make sure you know what we're doing and bring it on game day. Take a look at 3. Which of the following lines is a horizontal asymptote? Now, a lot of us are going to make a lazy Larry mistake on this. What do I have to look at if I'm looking to determine horizontal asymptotes? When you see a horizontal asymptote, what do we need to associate with that? John?
Degree of remaining design.
You're right to an extent, I guess, in terms of calculus. What calculus language, I guess, or calculus. Oh, that's another thing. You'll say something like calculus methods. So what calculus methods do we need to do to show one? Yeah. Yeah, and we need to consider what that function is doing as we go out to the left and the right. When you see this, the thing I need you to associate with a horizontal asymptote is a limit to infinity, but that's not the only one you look for. What else do you need to examine for? Limit as you go. We said limit to infinity, negative infinity. So how many limits to infinity do I need to take? 2. And you're right, we do need to look at the end behavior model, look at the degree of the numerator, degree of the denominator, the relative growth rate, all of that. So to start off with, I'm going to say this for 3. I'm going to do the positive limit first. And again, I looked and said, yeah, this is only going out to positive infinity, or sorry, this is going out to positive infinity. What's driving the numerator is a 3x cubed. What's driving the denominator is a 2x cubed. What is this going then to go to as we go out to infinity on the right-hand side? 3 over 2. Now, so that's one of them. Let's see if we've got another one. Looking at the right-hand side, I've got a limit as x goes out to negative infinity of this. Well, what happens when I start plugging in negative values in the numerator and negative values in the denominator, getting negative 3 times a negative cube and 2 times a negative cube? What is that going to as we go out to the right? Yeah? 3/2 again. Because you'd have the same negative number in the numerator and the denominator being multiplied by 3/2. So we're going to take and work that out. So therefore, you now know, and you have correctly shown, when it says to justify your reasoning, that's the reasoning that you need. That's as much as would be expected to be shown. By the way, does anybody know what those, I've used those 3 dots if we go over what it means. Therefore, yeah. Technically, I think there's like thus is proved or something. Sometimes you'll see, if I ever give you pages from a college textbook, you may see, sometimes it will say like QED, horizontal asymptote of it, and I think that's like Latin for thus is proved. And then take a look for A. We need to go through now and find the domain and range of this function. So I look at this, the domain is so easy. So easy. Who can tell me what my domain is going to be? Should be equal, Tom? You need, I know, I think it's Weiss doesn't make you, does Weiss make you show the U's?
No.
That's incorrect. Just so you know, otherwise there's 2 collections of points. The U is not optional, as much as some people think it is. Next one up, we need to find the range of it. Now, look at the numerator. You've got cosine in the numerator, and what's cosine sandwiched between? We talked about that before. What output values is cosine sandwiched between? -1 and +1. Are there any constraints on the denominator? What output values are you getting in the denominator? Or sorry, what input values are you getting in the denominator? Everything. So what would our range then be? If this is what you can find in the numerator, this is the denominator, what values can we get in terms of range or output values? No? Because think about that. If the maximum, you give a -1, let's say this. If I give a value like 2 or 3 or 4, this is going to be a fraction and it's going to get really, really close to 0. And by the way, can it be 0? Can it be 0? The answer is yes. Because does cosine equal 0? Sure. What about if I plug in, though, and this is where it gets awkward, something between -1? Let's say the numerator comes out to be 1, and you divide that by 0.2. What's 1 divided by 0.2 going to be? How many 0.2s go into 1? 5. What if I did 0.1 over 1? Or sorry, 1 over 0.1. What's that going to be? 10. What if I did 0.000000? Sorry, 1 divided by 0.000001. It's going to be a huge number. So your range, without the calculator, you should know, is -infinity to +infinity. Now the next question up asks if it's odd, even, or neither. This is something that we did back in pre-calc in your very first or second unit. To figure that out, you need to plug in a -x. If it's the same as and simplify. If it's the same as the original, it's even. If it's the opposite of it, it's odd. And if it's neither, it doesn't match either. So I'm going to go through, plug in a -x, I get that expression. Now here's what we have to go through and remember. What does the cosine graph look like? If I were to list it out, take a look at cosine. Remember, cosine waves look like that. And then if I were to give it out going, and it continues going on forever this way, but it also continues forever going that way. So if I plug in, let's make it real easy, 180 degrees, what do I get if I plug in negative 180? What do you know about the relationship between cosine, the inputs on the positive side and the negative side? They're the same. So what's cosine of negative x going to simplify to? Cosine of the negated input? Cosine of x. And then down below, what's the denominator going to simplify down to be? It's still a negative x. Now compare this simplified expression to the original. Is what we got when we plugged in a negative x the same as the original, yes or no? Is it the negation of the original, yes or no? Is it the same as the original multiplied by negative 1?
No.
Yeah, it is. Isn't it? Isn't the original cosine of x over x? Is that right? Yeah. This is the same as multiplying, hopefully we see this. If I took cosine of x over x and multiplied it by negative 1, doesn't that come out to be cosine x over negative x? So this is the negation, and if it's the negation, it's odd, since negative f of x is equal to f of negative x.
I thought it was a negative negated, not just one half, and that's one half.
Well, hang on a minute. What happens if I negate the whole thing? Two negatives make a positive and it's even. You have a negative in the numerator and denominator. That would be what you have. Now, the last one that we're going to do, you're looking at the limit of that as it goes to infinity. Does anybody want to take a guess? So what that function's going to go to is we go out to positive infinity. I got one of you, that's it. You can do better. You can do so much better. You tell me what?
0.
Why?
Because cosine can only be between 1 and negative 1.
So I can solve the answers. The numerator is always somewhere between 1 and negative 1, no matter how gargantuan that denominator ends up getting to be. Questions on that? Now, what we're going to have you all do is this. In a minute, we're going to release you in to working with your local force. That means you're going to get with each other and away. I love how. And I'll tell you this. I literally did that same thing I said. Popular students and pre-calcers that I had last year think it's hilarious that I do this for the group, class, like I get made fun of constantly. I literally brought it up in 4th class. I'm like, does this look like another what? No. So the joke is on you. It's perfectly normal behavior. So, get with your local fours. Now, what we're going to have you do is, there's a sheet over on the side here. You're going to send one delegate over. Please understand, you're going, listen, what I need you to do at the top of this, just so you know, is you're going to write at the top your name and all of your, well, actually, you're going to be working on it together, but you're handing it an individual for an individual grade. Make sure your name is at the top. I also need you to write, because I forgot to put it on the top here, you're going to need to write day 6 at the top. Okay? You're going to need to go through and write day 6 at the top. Now, if you go over to your sheet and look for day 6, we did the warm-up on a previous day. We did the quick quiz question, so now we're done. Practice worksheet over here. You're going to be doing the odd questions on this. And it's due next time we meet for a grade. Make sure you write day 6 at the top. You're permitted to collaborate with those around you, not with others. If you're outside of class, sure, but while we're in here, you work with the local force. So, let's see this. I'm going to give you 30 seconds. Get in your local fours right now, together and away from the other. Let's see how quickly we can get this done. Now, I'll send you up in a minute. Let's see if we can get this done in under 30 seconds. This group here is a little bit sloppy Sam's over here, and let's move up a little bit. Now, if you need more space, you can do it on separate paper, but I believe you have enough. Make sure you put the limit in front of every step that is required. You don't put it in front of the final answer. Go through and please pick that up. Get going. I actually got them done yesterday and then had my picture taken. It didn't make sense.
I like it though.
I look good. It's a curtain.